Welcome back to Start E-Learning. In the last class, we have discussed about these hyperplanes, half planes and subspaces. In the previous video, so we have discussed about these distance measures in the machine learning. Now in this video, we will see the dimensionality reduction technique, which is most widely used technique in the machine learning. Okay, so as we discussed in the previous classes itself, these complete deterministic and stochastic statistical methods completely deals with the machine learning itself. Okay, so now we will see what is a dimensionality reduction, what are the benefits of the dimensionality reduction, what are the advantages, what are the disadvantages, what are the features in this dimensionality reduction, and then what are the techniques which we are going to be used in the dimensionality reduction. Now we will see the formal definition of this dimensionality reduction. So formally in the pattern recognition, dimensionality reduction is defined as, so in the pattern recognition, the dimensionality reduction is the process of conversion of the data sets having higher dimensions to the lower dimensions. So it might be a dimensions or it might be a features. Okay. So the dimensionality reduction is the process of conversion of the data set having the higher amount of data, that is higher dimensions of data into the lower dimensions of data. So here one thing you might raise and doubt that here we are reducing the dimensions, right? Whether the obtained dimensions gives the accurate results as the data set having the higher dimensions. You might raise this doubt. Yes, absolutely. The reduced dimensions conveys or tells or results as same as the higher dimensions. Okay, so dimensionality reduction is a process of conversion of the higher data sets having the higher dimensions to the lower dimensions. The reduced dimensions conveys or tells or results as same as the higher dimensions gives. Okay, now we will try to understand this by using the example itself. So assume that we are going to convert the centimeters into inches. Okay, now I'll just try to take the data set, that is centimeters and inches. We know that 1 centimeter equals to 0.394 inches, 0.394, and then 2 centimeters equals to 0.788, and 3 centimeters equals to 1.18, and 4 centimeters is 1.57, and 5 centimeters is 1.96, and then the 6 centimeters is 2.36. Now we'll try to frame the graph for that particular data set. I'll just try to erase it. So now I'll try to frame a graph for this. So this is what the x-axis and this is what the y-axis is. So in the x-axis I'm going to take the centimeters 1, 2, 3, 4, 5 and 6. Now I'm going to plot the data set only for only up to 5. This 6 value is I'm going to predict from the reduced data sets. Okay, so a reduced data set, from the reduced data set I'm going to obtain this particular 6 value. Okay, so here I'm going to take from 0.2 to 0.4, 0.6, 0.8 and 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, 2.2 and 2.4. so this is what the centimeters is and this is the inches. Now I'll try to frame the graph for this. So 1 in the sense 0.39. I'm going to round this particular value 0.4, right? So 0.4 it is here, and then 0.78 in the sense if we round this value in the sense we'll get 0.8. 0.8 it will come here, and then 3 1.18. 1.18 in the sense if I round this particular value then I'll obtain 1.2, right? 1.2 it will come here. Then 4 1.57. if we round this we'll get 1.6. 1.6, so it will come here. Then if I take this 5 1.96 in the sense it is 2, right? It will come here 2. So 6 value I'll write over there 2.36. 6 values 2.36. we are going to obtain this value. See here, I'll just try to combine this, join these points. So this is what the obtained reduced values. So now we'll try to perform the operation on this. I'll try to check whether the output for this 6 will come or not. So I'll try to extend this value. So this line will goes like this, right? Like this. So here it is intersected. Now we know this 6 value is around 2.36, right? Now we'll try to join this. So approximately this particular value is obtained 2.36. see here likewise. So this is what the dimensionality reduction is. So what is dimensionality reduction? In the pattern recognition, dimensionality reduction is a process of conversion of data sets having the higher amount of data sets into the data set having the lower dimensions. Okay, so this is what the dimensionality reduction is. Now hope you got it. Now we will see the components of dimensionality reduction. Components of dimensionality reduction. So the components of the dimensionality reduction are mainly categorized into two. Those are feature selection and the feature extraction. Feature selection and feature extraction. Feature extraction. As the name itself suggests that here we are going to select the data, right? So here we are going to select the subsets of data. Selecting subset of data. So this can be done in three ways. So those are the filtering and wrapping up of data, and then embedding or embedded. So this is what the feature selection. Here we are going to select the particular data, and then when we come to the feature extraction, the name itself suggests that from the selected data sets we are going to obtain the we are going to extract a thing, that is we are going to reduce the higher dimensions to the lower dimensions. Okay, reducing from higher dimensions to lower dimensions. So components of the dimensionality reduction is categorized into two: feature selection and the feature extraction. The name itself suggests that feature selection is the process of selecting a data from the vast amount of data. So this selection can be done in three ways, that is filtering up of data, wrapping up of data, and embedding up of data. And then when we come to the feature extraction is the process of conversion of the data sets from higher dimensions to the lower dimensions. Hope you will got with these components of the dimensionality reduction. Now we will see the why the dimensionality reduction is important. Why dimensionality reduction is important. Okay, so by adapting this dimensionality reduction technique, so if we have the fewer features, in the sense the then we have the less complexity, right? So fewer dimensions, less complexity. Then so we are reducing the data, so absolutely we are reducing the storage, right? So less storage space, and then fewer features requires the less computation time. Here we have the less features, then we will have the less computation time. Fewer features, less computation time. And then model accuracy will be improved due to the data misleading. So whenever we have the vast amount of data, in the sense at that time there might be chance of misleadings of data. So here we have the fewer features. At that case the accuracy of the model will be improved. So accuracy of the model will be improved due to less misleadings. Okay, algorithms can train faster. So I'll try to explain here. See here. So in the normal programming languages, we are going to provide the input for the program. Assume that this is a program. Here we are going to give the input, then from the program we are obtaining the output. But in the case of machine learning, it is not the case. here we are going to give the input as well as the expected output. So this machine learning model from this input and from this output, it's going to produce an algorithm. Okay, it's going to produce an algorithm, or it might be a program. Okay, so if I give the inputs as 2, 4, if the output is 6 in the sense, what it's happening here, it is happening the addition operation. In the same way, so as we know, while training the machine learning model, we have to use the more amount of data, then only that particular model will give the accurate results. And if I give 3, 4, in the sense, what it will produce? 7. Okay, here expected output would be 7. Likewise, we are going to feed the input as well as the output. So based on these inputs, the machine learning model will produce the algorithm. So this is what the case is. So here, by adopting the dimensionality reduction technique, the algorithms will train faster. Okay, the algorithms will train faster. Okay, will train faster. So here we are reducing the dimensions, right? Whenever we have fewer features, in the sense, at that case it's very easy to plot the data. So fewer features, easy to plot. Easy to plot. As we know, in the machine learning, almost in all the cases we are going to use the plot, or we are going to visualize that particular data. Whenever we have fewer data or the fewer features, in the sense, it's very easy to visualize. Okay, and then it removes the noise and the redundancy in the system. Removes noise and redundancy in data, or it might be a system. Okay, so redundancy is nothing but the repetition of data. Okay, redundancy is nothing but the repetition of data, and noise is nothing but whenever we have the vast amount of data, at that case there might be a chance of misleadings, right? So that's what the noise is. Okay, so these are some why this particular dimensionality reduction is important. These are some of the advantages, or these are the importance of the dimensionality reduction. Then we will see the benefits. Okay, then we will see the benefits of dimensionality reduction. Benefits. Here it compresses the data and thus reduces the storage space requirements. Here itself I mentioned it requires less storage space. So the main benefit is less storage space. It compresses the storage space. It compresses the storage space. And then it reduces the time required for the computation, and the complexity of the problem is less. Reduces computation time, and complexity will be reduced. Then it eliminates the redundant features. So these are the benefits. Here itself I mentioned it removes the redundancy. Redundancy is nothing but the repetition of data, and then it will improve the model performance. improves performance of the model. Performance of model. So these are some of the benefits of this dimensionality reduction. Now we will see the advantages as well as the disadvantages of this dimensionality reduction. As we know, whenever we have the advantages, so similar way we have the disadvantages also. Now we will see about the advantages of the dimensionality reduction. So advantages, it helps in, I'll write advantages. So it helps in data compression and hence storage space. Helps in data compression and reduced in the storage space. Reduced in the storage space. Next, it reduces the computation time. You might just copy this and include in these advantages. It reduces the computation. Reduces the computation time. It also helps in removing the redundant features. Helps in removing redundant features. And then you can include this improves the performance of a model. You can include these points in these advantages. And then disadvantage. The mainly disadvantages of using this dimensionality reduction is here we are losing some data, right? Disadvantages. The main disadvantages of a dimensionality reduction is here we are losing some amount of data. Data loss. Losing some amount of data. So in the principal component analysis we have the many disadvantages. You can include that disadvantages in the dimensionality reduction also. Now we will see the dimensionality reduction techniques. Dimensionality reduction techniques. Mainly these dimensionality reduction techniques are broadly categorized into two. Those are the principal component analysis which is nothing but PCA, and then Fisher linear discriminant analysis. Fisher linear discriminant analysis. So this is LDA. Okay. So these dimensionality reduction techniques are categorized into two: principal component analysis as well as the Fisher linear discriminant analysis. In our syllabus, only principal component analysis is mentioned. Fisher linear discriminant analysis also it's very important in the machine learning. So in the upcoming videos, we will see about this, what is a principal component analysis, how it will work, what is the algorithm for principal component analysis, and some of the problems based on this principal component analysis. Thanks for watching. Please try to share with your friends and try to subscribe to our channel. Press on the notification button to get the more updates while we are uploading. Thank you.
Yeah.